Hello stats, welcome to Yak Math Videos. We are in the big house here, okay? So we are brought to you by, this is Aldi's version of the RX bar, and this is Aldi's version of lovely chocolate chip, gluten-free, even plant-based cookies. Does that not sound awesome? All right. Anyway, I need you to have this packet, chapter 14 notes packet. If not, write it down on a separate sheet of paper. Speaking of separate sheet of paper, I'd have one. Okay, so we've learned a little bit. In fact, we talked about page 1, page 2. We talked about page 3, page 4 already, page 5, page 6 was kind of done. That's kind of lame. Page 7. Then we started on page 8 the other day, and then we had the question at the bottom of page 9. Well, look, I'm not going to talk to you about the T distribution while you are possibly e-learning here. So instead, we are going to, and we got some great questions. I need you to go to the bottom of, what was that, 13? It looks like a 13, not the bottom, but I need you to go to page 13. It's this page, folks. It's this page, all right? Now, you are going to need to leave more room than I did. So you want all this work kind of over here because we're going to compare the T distribution and the Z distribution on 5 and 6 in our notes. You don't know about the T distribution, so it's all about Z right now. All right? So Apple Tree Supermarkets is considering opening a new store, but they want to make sure if the sales will undoubtedly hit 250. We want to say that. We want to be absolutely for sure. Because so they estimate a nearby store by sending field workers to collect data. So 40 samples, that's a good enough size. And they have a sample mean of 263,590. So yeah, that's above 250. Suppose standard deviation is 42,000. Finding a 95% confidence interval for the mean. That's a true, yeah, they're true average. All right, for all of the stores. Could be an Aldi. All right, so here is the formula that we have. X bar plus minus Z star. S over root n. X bar plus or minus Z star. This is Z star for 99% confidence interval. That's standard deviation over the square root of 48. You want to be in classic mode, or else you're going to do 42,000 divided by 2 root 10. That's going to be an interesting answer. So I know they rounded to the nearest dollar, but I'm going to always round to the nearest penny. Okay, so we've got the margin of error of $17,106.66. So I take the estimate, subtract the margin of error. That's my lower bound. I take the estimate and add it. All right, so, I mean, if I'm doing a study, I'm already looking, guys, like, yeah, we tested above. I'm feeling pretty good about this, but we need to look here. Like if a question said later, we're going to answer some question. We're just building a confidence interval here. We're not making judgments. I mean, it clearly tested over, guys. So, yeah. Great chance of being over 250. But take a look here. I mean, being under 250 would not be an outlier. You know, what percent chance? Like, I don't know, maybe 5-6%, but it wouldn't be an outlier. So it's not guaranteed. Do you have a good chance of averaging 250? Yes. But there's going to be samples of size 40, you know, that in real, like, again, we're talking about the mean being captured in here, right? But 250 is, in fact, anything below 250 is in this interval. So it's possible that the true mean is not under 250. I mean, it's not going to be much under 250. So, yeah, on this question, we're just making the confidence interval. But the fact that that the confidence interval dips below 250, we can't be undoubtedly sure that it's going to average at least 2. We're going to be pretty sure, but this does dip below 250 when you think about that. All right, anyway, we're just making a confidence interval on that one. And long story short. You wish to move into a certain lovely town. You want a home between that many square feet. Now, like, that's a lot, but this is actually real data from 8 years ago. You want 3+ beds and 3+ baths. With the aid of Zillow, you collect info. This was info that somebody collected. That's the median. That's quartile 1, quartile 3. Constructed 95% confidence interval for the population mean. All right, because you or your realtor is only going to get so much data, right? But there are a certain amount of homes in a town or a region. All right, so this is for the Z distribution again. Like, move your work over here because on the right side, when we talk about this later in class, we need to talk about the t-distribution, and we're gonna compare them. All right, so first off, that 305.0, I multiplied everything by 1,000. We need to go in terms of just dollars. So that's 305,000. This is a 95% confidence interval, so it's 1.96 times the standard deviation, which is 72,102. There's big. There was one home I think was a bit too pricey. Divided by the square root of 39. So you get a MO of 22,629.30. I'm going to add or subtract. So that's just a confidence interval. So let's say you hypothetically bought a home for $241,523. That's a very exact total. We'd feel pretty good about that, right? We'd feel, I mean, that's barely above. That's under. It's under the quartile 1. All right. So I would recommend getting this was easy, guys. You just get homes, collect data, and you got a confidence interval here. And if you're buying a home, you want to be on this side. And if all is good and it's an outlier, that's great. That's great for you in terms of the mean. And you know, if you buy a home on this side, you just want to live in there forever. All right, because you might be paying more than needed, and that's all right. That's going to be your forever home. All right, so then we are going to go towards the back. We're going to spend some good time in chapter 14. Okay. This is page, I think it's 17. It's this one. At the top of the page, it says pre-quiz questions. Now we got 3 more in this document, and then hence, a extra little assignment. 83, that's the sample size. Women in a certain town, all aged 30 to 39, had their blood pressure measured. Their sample blood pressure was 112.55 with standard deviation. That construct a 95% confidence interval for the true mean of women in this town. All right. 112.55 plus or minus 1.96. That's all we're doing. Let's find the confidence interval. 10.32 divided by the square root of 83. Okay, so can you see this? Kinda. Ooh, not bad. So again, here's what I'm doing in my calculator for this cutting edge graphics here in Yak Math Videos. I'm doing a 10.32, then I'm dividing it by the square root of 83 immediately. I'm immediately gonna multiply that answer times 1.96. That gives me 2.20. I'm sorry, 2.22. Didn't have to round to the end. All right, and that's it. That's just the confidence interval for the mean. We're not making inference with it yet. All right, is this our comparison one? This one might be fun here. Yeah, all right, now we're making some inference. Okay, now we're saying, is something true? A certain car company claims that its most efficient car gets at least 40 miles a gallon in optimal driving condition. 50 of these were tests in such conditions in a sample mean of not 38.25 miles per hour. That'd be too slow of a car. Miles per gallon with a standard deviation of blank was observed. Oh man. Uh-oh. That seems quite under. Let's find out. Is it true that they are liar, paints and fire? Can the company claim a true mean of 40? Now you can't say no because it tests under, because it's all about the MO. So we're going to construct a 99% confidence interval because we want to be absolutely certain. So don't look here. Don't jump ahead. Those are the facts, the descriptive stats we got. We're going to say the mean plus or minus 99% CI has a z-star of 2.576. Standard deviation over square root of n. Do this divided by this. Hit enter. Multiply by 2.576. You get a small MO. It's because that standard deviation is relatively small there, and your sample size getting bigger. So make the confidence interval 37.4 all the way to 39.1. Oh man, yeah, no chance. That upper bound well under 40. And if it was even not well under, as long as it's under 40, no dice. They cannot claim. They could claim 39, because 39 would be the interval, but they cannot claim 40. Oh no. All right, we're going to talk later about voting, margin of error. That's probably where you've heard it before. in polls. All right, it's a little lengthy here. A certain athletic test adjusts its scoring to factor in size and gender for its college athletes tested. 100 men scored an average of, whatever that test measures, and 100 women scored an average of that. You got the standard deviations for both. You would make two separate 95% confidence intervals and make some conclusions. Okay. Two separate ones. So here you're not, and like the last few two, you're not doing T. We're just going Z with this. All right. Not bad. That's their X bar. That's their S. That's their N. X bar plus minus 1.96. Standard deviation over the square root of 100. Square root of 100 is nice because it's 10. Okay, so that divided by 10 multiplied by 1.96. That's the margin of error. Lower bound, upper bound. Lower bound, upper bound. Now, don't worry about that arrow yet, but the men overall tested lower, right? But we'll take a look at these intervals here in a second. The women. X bar is 50.71. But interesting to hear what you guys can hear, to see what you guys can hear in the hallway. 50.71 plus or minus 1.96 times 6.19 divided by the square root of 100 to 6.19 divided by the square root of 100. Multiply that by 1.96 to get a mo of 1.21. So who had the higher mo? The men did. The women had a smaller standard deviation. They were a little bit more consistent. So their margin of error is going to be smaller. All right, so you make two different ones. So it's not like the women test better and they did better. We got to look at whoever won in the study, whoever had the biggest X bar, because that's a thing. We got to look at their lower bound. And we got to look at the other group's upper bound. So 48.95 is their upper bound. 48.95 is their upper bound. 49.50 is their lower bound. There is no crossing over. There is no intersection. Because there's no intersection, they don't overlap. There is a clear winner, and it's the women. The women definitely in the sample, we can say. If we put this out to all the athletes, similar size and whatnot, would probably score better. All right. Sorry, man, I try to give us a bone every now and then. Wasn't that question. Builds character. All right. That is it with your, that's it with your actual notes. Okay, so now I need you to get out a separate sheet of paper. Probably just going to need one sheet of paper, and here's what we're going to do. All right, so you're going to title this Stats Notes Assignment Chapter. No, don't do that. That's just from Chapter 30. That's from my notes. Stats Notes Assignment 2 whatever. If you're watching this on Wednesday, it's 2/12/25. If it's Thursday, you're out, it's 2/13/25. If it's both days, then I've got to make another video. I think it's going to be Wednesday, so it's probably going to be 2/12/25. You're going to let me know. You need to write all on a separate paper, and you're going to turn in the next day. I see you. I see the whole class. If you miss one of these days, scan an email. All right, so what I need you to do is multiple choice. You just say, test is 5 questions. All right, 4 answer choices. 1 is right. Assume random guesses. Let X be the number of questions you guess correctly. So say X is correctly guessed question. All right, then X has a binomial distribution of that. Pause it, write it down. You can abbreviate a little bit. So find the probability you guessed exactly. Sometimes the English on... I got this from SIU. All right, so go Salukis, except for spelling. I just got 3 out of 5 on pure guesses. What? All right, so probability X is 3. 5, choose 3. Probability of success is 2, 5. Raise it to the third. Probability of failure, 7, 2. You want to square it. Again, for those of us maybe struggling with the calculator, how do we do that? So 5, choose 3. You're going to go 5, PRB. Second choice 3, going to hit enter. Then I'm going to do times. So answer times was at 0.25. Raise it to the third. And you can hit enter if you want. You can do times 0.75 squared. Probably be in math print for this. I'll make it easier. 0.88. Let's go. Math print's nice because in those exponents, you don't have the caret symbol. It just puts it as an exponent. All right, so mode, I'm going to go down to math print. So you just see that exponent up there. All right, what's the probability to get at least 1 right? Come on. 1 minus probability x is 0. What's probability x is 0? 0.75. You're going to raise it to the 5th. I mean, what's the chance of missing it? It's 0.75. Raise it to the 5th. Yeah, so probably get at least 1 right. That's good. Probably to get no right, though. 0.237. It can happen. Try not to guess. All right, make sure you have that written down. That is, you just got 2 questions here. I think 5 total parts, so it kind of tells you how many points you might get for this. Be a bummer if you didn't get the points. It'd be a pretty big indictment. All right, so that was from chapter 13. It's from chapter 3 and 11. All right, so you can say birth weights have a normal distribution. If you want to say that, like X is birth rates. X is normal, 110 and 13. Find the probability a randomly chosen newborn has a weight of more than 121 randomly chosen. So you're going to say probability X is greater than or equal to 120. Z is X minus the mean over the standard deviation. Z-score of 0.77. You look that up on your Z table, 7794. I want to be... Again, you always do 1 minus if it's greater than. If you found an area using the Z table, the normal distribution. So notice we're getting confused in chapter 13 about when I did 1 minus. Again, you have to be using a Z table. Then if it's greater than, you do 1 minus that. But you got to be finding an area from a Z table. Okay? To always do 1 minus for greater than or equal to. If it's a binomial probability, you're not using a Z table unless, certain questions are, right? You have 500 bats, with probability you get 155 or more hits, then use Z. How much must a newborn weigh to be in the top 10%? So top 10%, that's the 90th percentile. Z-score of 1.28. We've done that a bunch. 1.28 is equal to X minus the mean or standard deviation. All from chapter 3, guys. Nothing really new. All from chapter 3. Multiply 1.28 by 13. Add 110 to it. Cool. Consider a simple random sample of 16. Now, 16 is definitely less than 30, but this data is from a normal distribution, so we're allowed to do this. We talked about that. In chapter 11, you need either a big sample size or from a normal distribution. So X bar is approximately normal with the same mean, and the standard error is sigma over root n. 13 over the square root of 16, that's 3.25. Guys, 110 is the mean, so you're gonna have a Z-score of 0. This may be the first time we've had this year. All right, Z-score of 0 literally is the 50th percentile. That's easy. 120 minus 110 over 3 1/4. Z-score of 3.08. Well, made a little boo-boo there. 3.08. Is that an extra 3? 9990. 9990 minus 0.5000. That's 0.4990. All right. Make sure you have all that down. That's 5 parts, folks. Expect to see that with your name on it when I see you next. This first thing you're going to do is going to turn this in. All right, folks. It's a long enough video. This is Yaakov Math Video signing out.